All right, we're moving into the last section of the primal workshop. So in the remainder time, so we'll have a panel discussion among 4 speakers, Christine, Sai, Helen, and Erin. So Helen and Erin had already introduced themselves and give this excellent invited talk. So here's how we are going to be organizing the panel discussion. So first of all, Sai and Christine will just briefly introduce yourself and your work, and then we'll move into you guys collectively answering a sequence of curated questions. And for the audience who would like to participate, I encourage you to add your questions to the Rocket Chat. So I'll be the moderator for the panel discussion, and hopefully we'll bring about some interesting questions and discussion about these topics that we talk about throughout the workshop. All right, so first we'll start with Christine. Christine is a research scientist and the Nexus research, and in particular, she had been organizing the NIST competition on differentially private synthetic data generation since 2017, and recently they have completed the competition, and she has a lot to say about it. So I'll let her introduce herself, and then Sai. Sai is a pioneer in differentially private and private natural language processing, and he has been he founded and has been organizing the private NLP workshops at almost all major natural language processing conferences, and we'll be happy to hear some experience organizing these workshops over there, and some interesting challenges on privacy in building natural language processing models. All right, please go ahead and introduce yourself, and we'll get the question started.
That's good. So I think you got basically the gist of it. So I'll say for international participants, so NIST is the National Institute of Standards and Technology in the US. It does a lot of things like set cryptographic standards. It also keeps track of the canonical peanut butter and length of the meter and so on. And so one of its roles is to assist when research is moving from research to production, to provide common benchmarking tools that can be used for, to support industry competition, measuring possible solutions and so on. So as part of this, for differential privacy, we've been doing a series, and I work for Nexus Research, I'm a contractor, but NIST has been doing a series of challenges over the past several years focused on synthetic data. And a big motivation for this is that a lot of national statistical agencies across the world and in the US see synthetic data as one of the great mediums. Data is a great medium, right? So this is a way of releasing data to the public in a privacy-preserving fashion so that it can be used for future analysis, ideally, safely, both in terms of privacy and in terms of utility. So safe in the sense of not leading to misleading or problematic conclusions for the folks who are using this for analysis. So this is a big problem, and I think the question that gets focused on me lets me ask a bit more, so I will leave you to wait for that, and I'll turn it over to Sahi.
Thanks, Kristen, and thanks, Yushan. I think Yushan already gave quite a good intro. I'm currently at Meta, Facebook, been working on privacy-related research there. Most of my work on natural language processing and privacy happened while I was at Amazon, so lots of work going on there within the NLP and Alexa workspace. I think we would have some time to dive into some of the specific questions there, so I'll stop right there. But yeah, excited to be here.
Sounds good. So why don't we get the question started? So we'll start with Christine. So you talk about this NIST competitions on differentially private synthetic data generation. So what are some main takeaways from the 3 years of running this competition, and what are the things that we could learn as a community building differentially private and generally private model for machine learning models?
Absolutely. Thank you for asking. So I would say the way to think about synthetic data is that it's basically machine learning in verbose mode, right? So The way you do synthetic data is you generally take your input data, you ask a batch of queries, you produce a model of that data, and then you use that model to generate a new data set that matches the distribution of the input data. And so what you're getting to do is, instead of doing machine learning where you feed the input into the model, train the model, and then just get a classification stamp on new data, instead you're getting an entire data set out. And so if there's any sort of flaws or problems or oversights or biases or whatever in your machine learning algorithm, that's going to be reflected in the output. And so it makes exploring the utility of synthetic data especially interesting for understanding the mechanics of machine learning. So some important things to take away from that. First of all, I hate to say that, but over 4 years, we saw a lot of differentially private synthetic generators sort of crash and burn. The structure of the challenge was such that, and this is a very common scenario in the real world, these agencies that are producing data, they've already released historically anonymized data. So, and they're wanting to transition to more formal privacy. So the structure of the challenge was everybody got sort of a public data set that they could use for developing their algorithm on basic structures, basic properties of the data. And then they were evaluated, scored, and ranked based on private data that they never got to see. And the private data had the same schema as the public data, but we like to do nice, tricky things to them on the distribution. So for instance, we got the public taxi data from 2020, but we scored them, or on 2016, but we scored them on pandemic taxi data. So very different distribution, just the same schema, right? And what we found is that a lot of algorithms that sort of performed well in academic research in some sense, actually performed very poorly on real world data. And this was due to, as near as we can tell, a variety of factors. There would tend to be inefficient queries, so that you're asking many queries and sort of raking that sensitivity up without getting lots of information in each query. You kind of really need to make that as efficient as possible. And also this tendency to not look at all at where the data lives inside the data space. And so there were very general properties about the relationships between variables, ones that would hold, all across the country, all across decades of data. So they weren't, attributable to any individual, no privacy leak or anything like that, but very general ideas about the dimensionality of where the data actually lives, as opposed to the whole schema space, that turned out to be extremely useful for being able to model it accurately, efficiently, and well, both for differential privacy and in general. We found that sort of simple marginal queries with a little bit of noise and probabilistic graphical models outperformed GANs significantly. And in the end, we saw results, this is very important, they were actually able to produce better utility than traditional redaction techniques. So significantly better privacy because it's formal privacy, but actually also better utility. And so we think there's a lot of promising work to be done in that direction.
Yeah, that sounds like a very interesting breakthrough, that it also improves utility with DP tools. And the kind of technical elements, many of them seems applicable to machine learning. For instance, this access to this additional data set, this using the public data schema and probabilistic graphical models to somehow exploit the structure in the data itself. Right. Yeah, thank you for sharing.
I will say real quick, I'm going to drop a link in both chats. Anybody who wants to play with us themselves, they can. So everything's up online. 3 of our winners open sourced their solutions, spent all summer making them user friendly, so you can play with them on your own data. And we're going to have benchmarking tools out later this year that you can try everything out on our own real world data with nice evaluation and pretty visualizations and the whole deal. So thank you.
Awesome. Sai, you want to go next? So this is a question about the privacy in NLP community. So what are some unique privacy challenges in NLP problems, and how can the primal community somehow contribute to this problem?
Sure, thanks. I think some of the problems can be, you can extend them from some of the conversations we've actually started having today. The first one I'll start with would be synthetic data generation, but you can think about that within all the complexities of natural language generation. So utility, first of all, but the other thing would be trust in the underlying generation techniques. And obviously extending from that is privacy, so formal and empirical guarantees, and obviously other things such as fairness, which are tangential. So one question is, how do you balance all these things in a way that people are comfortable with, and the people who are using the techniques, so those will be like the corporate players, still get utility from that? So that's the first thing. The second part is, if you take a step back to figure out why people have privacy enhancing technologies in their workflow, apart from the common good that derives from it, most times it's about compliance. And so the next block of challenge is, if you take a compliance regime, take anyone like GDPR, how do you go from the legislation to formal requirements on something that you can reason along the lines of, from the lens of the legal folks, but also from the lens of like the theoreticians and the engineers? So if you take something like GDPR singling out, for example, how do you implement that in a differentially private manner? And how do you like build engineering tools around that? So I'll say that will be the second block of problems that I've seen. The third block sort of also extends from the first two, which is how do you validate everything I've talked about? How do you validate the utility, especially if you don't want to do it in an ad hoc fashion where you take model 1, you validate utility on model 1, you take model 2. So is there a way to have a uniform way to optimize the utility? The other question would be empirical privacy, and what does that mean? So it's all well and good to select strong values of epsilon, but the question is, what does that mean? And yes, there's a probabilistic guarantee on what it means, but if I take it to, I don't know, a product manager or a legal counsel, how do you communicate that to them on something that they can reason about? And how do you also select these parameters? So epsilon 0.1 is good, epsilon 100 is bad. What about the values in between? How do you trade off and choose these parameters? So I'll say those are the kind of really sticky problems that I've seen over the years.
Well, yeah, we'll be touching. We'll be hoping to touch upon like several of these dimensions, like in the remainder of the panel discussion. But just anything specific to NLP problems, like comparing to the general, say, privacy problems in applying machine learning to sensitive data.
I was just going to mention one other thing that I'd written in my notes when Helen was talking. I think one other problem is also generating these data while sticking to very, very narrow normative definitions. So for example, if you feel that people are fine with disclosing a very narrow set of properties, how do you then define machine learning models that only generate data to specify that, and then extend that to all the empirical validations and stuff?
Right. Yeah, I say that some aspect of that has something to do with the type of the data. For instance, I can say a lot of things that are not so sensitive about myself, but there are also other things that I could say my private conversation with my kids, with my family, and I don't want them seen or reviewed. So different like text sequence could have different privacy risks associated with them, and so on. Yeah, so I think now is a good time to move to Helen. So you gave an excellent talk earlier today, and your work addresses the broader privacy issues from very different angles comparing to some of the technical aspects of that most attendees of this workshop are familiar with. So in your opinion, so knowing what differential privacy is, what homomorphic encryptions and so on are, What are some examples of privacy problems that are not addressable by these existing tools? Yes, that we covered in this workshop. Yeah, Helen, you're on mute.
Don't tell me. Don't tell me.
Okay.
I know how many times I've done that. Okay, so thank you very much. And I'll try. I'm a little worried about Erin having to rush off. What time do you have to go, Erin? Because I'll try not to speak for that long.
Okay, I have to pick up kids in 15 minutes, but I've got
okay, all right,
minutes.
definitely no problem. So thank you. I'm so grateful for the opportunity, and it's so interesting. I mean, I tried to listen to bits and pieces of people's talks to the extent I was able to follow. So, for example, even this comment I think Christine had just made, you know, better privacy, better utility. Like, if I'm talking to this community, I want to say, like, what do you mean when you say better privacy or better utility? Like, just jog people to say, all right, this is what I mean when I say that. And because I think that hidden in there are some assumptions that almost, they almost preview what the upshot is going to be. Like, they're hidden definitions that are, and so it's like a little bit to say, yeah, I know that that's not where you're shining your light, but maybe if you did dig into those assumptions, you might be surprised. And then you might ask whether the techniques that you're developing based on those assumptions are a little bit like a hired gun. You know, I can serve evil as well as I can serve good. And I think what folks like myself are trying to do is trying to make, you know, understand that. So I have two quick comments about secure computation and homomorphic encryption. And so, and I don't know if DP fits in these comments, and I happen to be working on a DARPA funded project at the moment that's saying, look, there are all these cool things that cryptographers and applied cryptographers have developed. So my problem in that domain is, like, why aren't we seeing them in use when in fact they actually fit some of the threat models? For example, you know, private information retrieval. Why isn't this being used in many of the myriad of search functions that services and platforms are offering us? So in that instance, I'm super impressed with kind of the brilliance that goes into these mechanisms, and then saying, like, what's the world going to have to do to nudge these mechanisms into use? And I don't know, maybe DP has a similar challenge, but the point I really want to, so some of the talks that I just kind of dipped into were saying things like, what about if the training data has this problem or that? You know, what about if the training data, maybe Erin's was a little bit in this way, like maybe the training data has private information. And again, I'm pushing you to say, well, what do you mean by that? But I really want to think about the opposite, the down, you know, which is to say, like, I'm sure everyone remembers the gaydar case. Social network structures can reveal, if you analyze them, to a high degree of probability whether somebody's gay. And so I don't know if your community is thinking about this problem, but what when information you don't consider to be private, sensitive, where it has very limited constraints on it, suddenly pops up through these analytics, through the machine learning, is able to reveal what we may, on the other side, consider to be information that the analysts are actually not entitled to, if you want to use a little bit more the CI language. And I'm wondering, is there a community of folks in, you know, in your primal community who are thinking about that question? Anyway, so those are just a few thoughts.
Yeah, we are already seeing some interesting discussions along these lines on inferential privacy and how making things just available, like even if this has nothing to do with the differential privacy, notional privacy, by adding or removing any individual, it doesn't really affect the outcome. And you are able to predict who's gay and who's not based on these data if you have those data available. Yeah, I think that's really a key point. That's one of the things that I don't think we have a good tool for. Yeah, as illustrated by this smoking causes cancer example, right? So the harm will be drawn by this analysis, by this study to those who are smokers. But like it decomposes the kind of risk of participation in this data set to the risk of that's associated with these inferences that you can make about the outcome of this data analysis.
I mean,
so maybe Erin has,
say, if I'm understanding you correctly, some of your comments were getting at that. Okay, I'll shut.
All right, yeah, maybe Erin has something to add there, but let me ask this question, which I think this is related. So you've been leading the differential privacy research and differentially private machine learning research for a couple of years now, and you literally have written the book with Cynthia Dork, and which has been the book that everybody uses for their courses and so on. So what are some key successes and limitations of the DP community's effort in addressing these practical privacy challenges, and what do you think that we could have done better, like if you look at it from hindsight, and in particular those practical privacy challenges that Helen spoke of?
Okay, cool. It's a big question. Let's see what I can come up with. So I think differential privacy is a very good solution for what in Helen's framework is a narrowly constrained privacy problem. And I think that within the differential privacy community, so sort of the kind of privacy that differential privacy promises and the kind it does not is widely known. But it seems that as a community, we've perhaps done a bad job of communicating these subtleties, because when we see differential privacy used as like a buzzword increasingly in the corporate world, maybe it's not always communicated the kinds of things that differential privacy does not promise or protect against. And in particular, I think the main one, which people often mean when they use the word privacy in English, but that differential privacy does not protect against, is sort of what you just mentioned, inferential privacy, right? And this is related to the target example that Helen mentioned in the Q&A session after her talk, right? Like, differential privacy doesn't stop me from discovering population-wide correlations that might allow you to take features that I make publicly available because I thought they were innocuous, but correlate them with things that I might be embarrassed about, right? So in the target example, which may or may not be real, but for the purposes of the discussion, it doesn't matter. For folks who didn't read this New York Times article some years ago, the premise was that Target could accurately infer whether their customers were pregnant and send them, like targeted ads at pregnant people from innocuous purchases they had made, like hand creams and stuff. Right, and this is the same as the sort of gaydar example, right? Like, and ultimately this is the same as smoking causes lung cancer, right? Like, before 1950, when we didn't know about the link between smoking and lung cancer, you would have thought whether or not you smoked was not something that you had to keep private, and you might have had a mental model that was consistent in your mind, in which you wanted to keep, which you didn't mind making public your smoking status, but in which you really wouldn't want people to have information about your lung cancer status. And then it was discovered that there's this link between these two things. Okay, like the gaydar example is quite similar. You might have thought that, like making public what things you like and what groups on Facebook you're a member of is innocuous, you don't care about that, but you want to keep your sexual orientation private. Well, okay, maybe your mental model has to change when you realize that it's possible to predict all of this stuff from the huge amount of digital exhaust that you thought was innocuous that you're now producing. So differential privacy doesn't address this because it explicitly allows, the whole point is to allow you to learn population-wide statistics about data while hiding individual contributions. And this is obviously an important problem, but it's a very tricky one. Like, I don't know how one would go about solving it short of locking down all of your data, because it's very hard to anticipate what can be predicted from what, with like statistical methodologies or data sets that are not yet available, right? Like, in the last decade, we've become much better at machine learning, at predicting features from other features. And I wouldn't be surprised if like, just as the person who didn't want to have his lung cancer status, be disclosed, in the 1950s, but didn't mind having his smoking status disclosed, or, people in the last decade who didn't want to have their sexual orientation disclosed, but didn't mind having their social network activity disclosed. I wouldn't be surprised if there's stuff that we all think of as totally innocuous right now that in the future will turn out to be highly predictive of things that we might not, want to be known. And yeah, if people have good ideas for like how to address this, I think it would be like really interesting, because on the one hand, like, you can try to like lock down all your data, but that's very costly for all sorts of reasons. On the other hand, you can, I guess you could try to like regulate the kinds of inferences you're allowed to make, but that also seems quite problematic, right? Ultimately, I don't need machine learning tools to make inferences. Are you really going to make laws about what I'm allowed to sit in the corner and like introspect about? That seems tricky. Anyways, I've gone on for too long. This is a big part of the privacy problem that differential privacy doesn't address. But I don't know how to address it. And I'd love to hear ideas that people have.
Perhaps the contextual integrity framework and its extensions could provide some guidelines on how we may go about like addressing these issues like down the road. Just
a quick word to Erin. So we're not going to try and stop inference, i.e. Erin Roth sitting in his study and, performing some machine learning, but we also, again, maybe we open up to the parameters and say, well, but if you're the NSA and performing the inferences, then maybe we're going to try and regulate what those folks can do, or a large insurance company and so on. So we try to utilize all those parameters and see if we can wind up with more sensible policy than I think some of the regulators are thinking of.
Well, let me quickly move into the next questions. So Erin may catch this question and be the first one to respond to it. So as differential privacy transforms into a more applied research area, the need for empirical comparisons of algorithms arise, right? So the question is that how do we fairly compare DP algorithms in practice? So there are like two different ways. So one, we could just align the theoretical epsilon parameters that we set for our algorithms, but there are people, say Ilya wrote a nice paper arguing that this would prefer less private algorithm with a tighter analysis. On the other hand, like one could alternatively use large epsilon and then use practical attacks like membership inference attacks and canary insertion attacks and so on to evaluate the privacy like their response to these empirical attacks. But that also seems to be like losing a lot of information, in particular the formal guarantees that we get from DP, right? So what do you guys say about this issue, and how do we come by and design like a benchmark that fairly compare algorithms?
So maybe I'll just say something briefly before I have to run to daycare. So it's true that if we just line up the epsilons, then algorithms that are in fact more private than their analysis suggests will be at a sort of disadvantage in the accuracy evaluation. But I don't think that this is going to be a serious problem, like in the long run, in the event that differential privacy is adopted as a important technology and has lots of like scientific and development cycles behind it, because I think pretty quickly people will start coming up with pretty tight analyses for their algorithms, and there are tools to do this now. I mean, you have a Python package that lets people, quite accurately, apply sort of very modern privacy accounting technologies easily to algorithms. So, like on the one hand, I don't think it's bad if benchmarks have the property of incentivizing people to tighten their analyses, because I think ultimately, right, like when you're deciding on your privacy parameter, it's a two-dimensional, like optimization problem. There's no right answer. You're always trading off privacy and accuracy. And we are all better off if we make that decision with our eyes open, meaning actually understanding what this trade-off curve looks like, as opposed to like just guessing because like we did a bad job of analyzing the privacy parameters. Right. So on the one hand, benchmarks that set up an incentive system for analyzing things tightly, I think, are good. And second, I think that the problem of having algorithms that have very loose privacy analyses, it's going to be something that sort of goes away as the tools emerge to more easily come up with tight privacy analyses. So I'm in the camp of line up the epsilons and trace out the privacy trade-off, privacy accuracy trade-off curves.
Yeah, that's a fair point. Do you need to leave now?
I do, but I could leave like this avatar up if you want to continue having my company here.
Sounds good.
I'll do that.
Anyone want to add to this question on empirical evaluation of private algorithms?
Do you want to go first? Say
yes, go ahead.
Yeah, sure. I can talk about the other point. And I think what makes the other point tricky, that's having empirical evaluations, is I think the first thing you need to start from is you need to have, or I like to have, a formal representation of what you want to analyze. So if you want to take membership inference, you need to decompose it into a mathematical problem that people can reason about. Once you get that, you then need to figure out for these privacy guarantees I want, what tests are necessary and which ones are sufficient. I think once you can get all that done, the hard part becomes the implementation. How do you know that your membership inference machine learning model is good enough to interpret what you're trying to do? And how do you know that the ML model that you use to build the evaluator is good enough? And if you want to do something like linkability or attribute inference, then all these things start getting very tricky. And it's almost like the same in cryptography. How do you know your implementation of certain cryptographic protocols are correct? So that's what makes lining up the epsilon appealing. But I think for practical deployment, it gets really, really constrained. And that's why these empirical approaches are equally more appealing.
Cool. Christine, anything to add?
Yeah, I've got a couple things. So one, I think this is maybe also in light of something Helen mentioned earlier. So and something I didn't really go into detail on, but when synthetic data is verbose, it lets us do more than just say, this one's better, this one's worse. It lets you get in and see where your models have problems and where exactly, what portions of the population you're seeing weakness and utility. And one of the things that, which is the level before you go do deployment, that's the level you should be looking at things. And we do this using three marginals. It's a whole lot of three-dimensional snapshots of the data overlapping that lets us kind of zero in on what portions of the population we're seeing sources of disparity between the real and the synthetic data. But one thing you learn is that there's looking at things on the same utility level. So I agree. I think epsilon and delta and having height analysis and being able to fix those parameters, that makes it very nice for looking at comparisons on privacy. When you start looking at comparisons on utility, there's a good chance that once things are getting better, there's not going to be a single winner, right? So it's going to be, there will be some things that are definitely losers. But there's also going to be, this algorithm performs better on data with this sort of structure or properties or this sort of mechanics, or it does better on this portion of the population or something. And being able to, when we go to do benchmarking, doing benchmarking that makes it very clear what these differences are, so that, I'm not going to say you can choose the one that's right for you, because inevitably that's going to be an impossible problem, but so that you can understand the functioning of the system is going to also be part of this. So I'll say again, if you go look at the link I dropped, there is actually a library that will be coming out in a few months, has a nice visualizer, and you can go see sort of which communities across Ohio and Indiana, or so Ohio and Illinois, so in Chicago and so on, you're doing well or poorly on. And that can kind of help a little bit with that sort of thing. But one last thing, sorry. So with survey data, which what I deal with most, you have a problem when you try and do the empirical re-identification check, in that if I have 1,000 copies of Bob, he's a very mundane person. There's 1,000 other people who behave exactly like him. They're clones in the data. My synthetic data had better have some copies of Bob, because otherwise it's not reflecting the input distribution. And if I've got data that's got few enough features and a large enough number of records, there's going to be a lot of copies of Bob in it. At which point, if I can find Bob in the synthetic data, is that really a re-identification attack? So I think empirical tools for checking privacy are very useful. But inevitably, they end up in a debate about what does it really mean to re-identify somebody. And so anybody who has wisdom on that, would love to hear it.
I think you're absolutely right that especially for utility, so there are multiple dimensions that one need to look at, and there's usually not one single algorithm that's uniformly better than the other algorithm in all some circumstances across all the dimensions. I argue the same for the privacy parameter, right? So epsilon and delta, so with just two scalars, is like an overly simplified summary of the privacy guarantee that an algorithm is providing for this application. So yeah, I have no trouble like adding empirical evaluations to that as long as they are reported together with the provable epsilon delta DP guarantees, and they're also like a family of methods that allow you to generate more comprehensive privacy report that allows you to look into this problem a little bit more. So similar to utility. So on the privacy front, there are trade-offs to be made. There are multiple dimensions that we can measure and look at to see what could happen. And Helen, do you have anything to add here? Because I think epsilon delta DP, like in differential privacy, they only cover a very small portion of the kind of privacy concerns that the people care about, right?
Yeah, I mean, I think that the sort of meaty parts of it are the conversations that we were having previously. Is like, there's a certain threat model that DP is really excellent at. But there's so many others that folks who are more looking at privacy as a societal value, still with an intersection to technology, obviously, that sort of fall outside of that. So yeah, but I have nothing enlightening to say on that subject.
All right, and the other point that Christine made is that different algorithms could have different effects on the accuracy in different communities and different subgroups of the population. So there is actually an interesting and growing body of work that talks about the fundamental trade-offs between privacy and fairness. Which in the TLDR version of it is that sometimes you cannot have privacy and fairness at the same time, right? If you want differential privacy, then you have to discriminate against some subgroup of the minority population. And usually it is underrepresented groups that are hit most strongly by introducing differential privacy. So this is question to everybody. But are these trade-offs between fairness and privacy, so under, say, the contextual integrity framework, present under this like broader definition? Because you did talk about other aspects like ethics and fairness and so on, and I guess a related question is how do we reconcile these dilemmas?
Well, I poke at that question. I don't like the question, with all due respect, because what I want to say is that I mean sorry, I'm being a little bit facetious, but when you perform the analysis and you're looking at specific data flows according to the CI norm, then what you may find is that certain norms would challenge fairness. You know, that you would find that you would have bias outcomes, and in that case, you just need to privacy incorporates some of these values, not always. You know, sometimes there's fairness aside from that, and yes, sometimes there are trade-offs, but it isn't, unless you are committed to this idea that privacy means across the board reduction of data, then you can talk about such things as trade-offs between privacy and fairness. But if you're thinking about privacy as appropriate flow, then it isn't necessarily simply a minimization, and you could avoid a lot of these so-called dilemmas by insisting that minimization or secrecy is the right answer for privacy, if we're thinking of privacy as contextual integrity.
I see. Yeah. In these works about trade-offs between privacy and fairness, they are usually using differential privacy as a definition, right? So instead of
privacy, they're using privacy as avoidance, like the prevention of exposure to the world of certain type of data, and that is just one use case. And what we're interested in is like norms that govern different kinds of flows where the recipient could be somebody else, you know, where we constrain, you know. So sorry, this is such a fascinating set of questions, and I would like it really through in detail, but I'm looking at the time yeah.
I'd like to add something on this question. Quick. So first of all, when you're looking at what techniques are being used for privacy currently, and in the sense of, so as Helen said, you can do access control for privacy, right? You can make sure the flow is appropriate. So you can fill out all the paperwork, wait 3 months for a background check, and get direct access to CDC data or census data or whatever. Sometimes 6 months if they lose your record, 9 months for me. But anyways, eventually they may let you through. There's a problem then, though, in terms of access. You have to be able to maybe physically go to this location. You have to pay to be there. You've got to pay for your hours while you're working with the data. And so being able to release things more generally is in some sense a fairness ethics type question, because the more accessible that you can make some of this information, then more perspectives get to analyze it. So if we are in a non-constrained flow sort of situation, you can look at what privacy techniques have been done in the past. There's things like cell suppression, which was used on the CDC data. This is like k-anonymity. And there's a problem with that in that it tends to take populations that are diverse or complex. And if you throw in something like geography, like say county, We take this group that may be, an interesting whole group that you can analyze safely with individual privacy, but it gets shattered across the schema, so that, rather than having hundreds of thousands of people in this category, you've got just a few in each county, and then their data gets redacted due to cell suppression. And so actually, some of the impact of traditional privacy techniques for this data release tends to be very biased, and it's been going on for years and nobody's been looking at it. It prevents analysis we'd like to do on racial disparity and COVID outcomes because in rural areas, because a lot of that data got redacted when it was publicly released. So one of the things we look at is that synthetic data with nice machine learning models that do a good job of capturing the actual structure of the data may help address this. And I would say that although if you look at it in certain constrained theoretical ways, that you have that privacy fairness trade-off, when it comes to actually making things to run on real data, there is a huge amount of room for improvement on both, right? So we're well away from the point where one more point of accuracy would take us one more point away from fairness. And a lot of what we see when we go to do tuning is that we can improve performance across the board for everyone. We do try to, in the niche challenges, but also in my work with census and elsewhere, we try to be careful about, it is a first and foremost point to be careful about evaluating to make sure that we are getting good performance across not just the big monolithic group in the middle that's easy to model, but the more complex and interesting groups. And that's my pocket rant on that, which I deliver about once a week these days. So.
Yeah, that's a very, very nice perspective. And I guess adding multiple dimensions to the utility evaluation could somehow help with this issue. And Helen, I completely agree with your comments on this set of questions. So we're at the half an hour mark, 45 minutes mark. But I just want you guys to give like answer one last question with a very, very short, maybe one sentence response. So from the I guess policy perspective, and how do we argue for or against the use of formal privacy techniques to comply with the specific legal restrictions, and how do we know or enforce whether like companies who are claiming they're actually implementing these methods are actually doing that? I just throw in some ideas, and we don't have time to get into like the gory details on the answers.
I can just say, you tell us what it would take for us to be able to audit the internal practices of the companies. We just desperately need that so that we can validate that policies are being followed.
That was the exact term I was also going to use. I think we need auditing mechanisms. Those auditing mechanisms can take different shapes or forms, but that's always what it comes down to for policies, and especially the intersection of policies and machine learning.
I end up caring about utility. I'd say, as far as if companies are managing to adhere to their own privacy policies or legal privacy policies, my understanding is that even with GDPR, sometimes the legal interpretations that get accepted are like much weaker than anything any of us is striving for. And so I am very happy that there are other people focused very hard on that problem, and I'm focused very hard on the utility and fairness one right now.
Awesome. Yeah, thank you all so much for the discussion on this interesting topic.